So, hopefully you're okay with the unit circle 1 last lesson. Again, for exact values and radians, make sure you watch Mr. K's video first on the tile. But I'm just going to quickly go over the basics of it as well. So make sure you copy it down, pause the video, you know what to do. Alright, so the gist of this, you don't need to know everything. Next year you'll be explained everything in detail when you do methods. But all you need to know for now is angles can be measured in degrees or in radians. That's why you probably notice on your calculator we always say, put your calculator in degrees mode. You notice there's a rad mode, that's radians. Anyway, all you need to know is 360 degrees, so one complete revolution of a circle is equal to 2 pi, and that little symbol there means radians. It's a little C symbol at the top. So 360 degrees equals 2 pi radians. So if we had half a circle, 180 degrees is equal to pi radians. And again, if you had 90 degrees, it would be pi on 2, so half a pi radians, so pi on 2. I'll write that down for you. So if you had 90 degrees, it would be pi on 2 radians. Okay, so that's pretty easy. Next thing we need to know, conversions. To convert from degrees to radians, all you have to do, whatever the degrees is, you times it by pi over 180. And hopefully we'll give you nice numbers and they'll cancel. And alternatively, radians to degrees, you times it by the opposite of that, which is 180 over pi. I'll show you an example in a minute and it is super simple. Okay, so you're going to have that in your notes and you'll be able to do it in a minute. Okay, so I'm teaching you the theory first. The next thing we've got are called exact value triangles. So only in a few circumstances can you have a triangle where you work out sine theta, cos theta and tan theta, and you actually get whole numbers, or in this case, whole numbers that are fractions. So I'll explain what I mean here. So here we've got a right angle triangle, and it's an isosceles triangle because both of these sides are 1. And if you work out this other side length using Pythagoras' theorem, you get that one's root 2. Okay, and both angles here are 45 degrees because it's an isosceles triangle. So hopefully you're okay with that. So this is called the first exact value triangle. So when we work out sine 45, doesn't matter which angle we use, we'll use this one now. Sine, if you remember, is opposite over hypotenuse. So sine 45 is opposite over hypotenuse, so it's 1 over root 2. And that's the first one. Sine 45 is 1 over root 2. Our next one, cos 45. Cos is adjacent over hypotenuse. So adjacent is 1 over root 2. So it's exactly the same again. And tan 45, remember that? TOA. Tan is opposite over adjacent. So it's 1 over 1. So 1 over 1 is equal to 1. So they are your first 3 exact value ratios that you need to remember, or you write them down in your notes anyway and you refer to them. So sine 45 is 1 over root 2, cos 45 is 1 over root 2, tan 45 is 1. And if you can remember this triangle, you'll be able to derive those for yourself. Alright, let's move on to the next little board. And here's our second and our last exact value triangle. So this time we've got a right angle triangle. This is 30 degrees, that's right angle, so that's 60 degrees. And our sides are 1, 2 and root 3. 2 is the hypotenuse because it's the longest side length. It's longer than root 3 and 1. Alright, so for each of these, for 30 degrees we can work out sine, cos and tan of 30 degrees. And I'll do that with you, I'll show you how I get the answer. So sine 30, sine is opposite over hypotenuse. So 1 over 2. Remember sine? S-O-H. Next one, cos 30. Cos is adjacent over hypotenuse. So it's root 3 over 2. And the last one is tan 30. Tan is opposite over adjacent. So 1 over root 3. And then the first 3 exact value ratios for this triangle. And now we can do the exact same thing for sine for 60 degrees. So sine 60 is opposite over hypotenuse, so it's root 3 over 2. Okay, the next one is cos, adjacent over hypotenuse, which is 1 over 2. And the last one is tan 60, opposite over adjacent, so it's root 3 over 1, which is just root 3. Okay? And you'll notice in the textbook, if we go back up to this one, root 3 over 2. Oh no, it's all good. No, let's just ignore me. Go back to this one over here. 1 over root 3. Remember, if we multiply, rationalise the denominator, we multiply both by root 3, we get root 3, and that on the bottom line becomes 3. The textbook do that a little bit, just so you're aware of what they're doing. Alright, and that's called the exact value triangles. Alright, now let's just do an example. I'm going to do a couple more examples of all these concepts we've just learned. Let's start off with converting first. So convert 120 degrees to radians. So the first thing we do, 120 degrees. Look back over here, and degrees to radians, what do? We multiply by pi on 180. Come back over here, we multiply by pi over 180. The 120 is on the top line, so if you remember that's over 1. So we can cancel the 120 and 180, that becomes 60 goes into that twice, 60 goes into that 3 times. So on the top line we've got 2 pi, and on the bottom line we've got 3. So there's your answer. And it's 2 pi over 3, and you put a little C symbol for radians. That wasn't too hard, was it? You just had to multiply it by pi on 180. The next one, convert 5 pi over 4 radians to degrees. So I'm going to write up this 5 pi over 4. Now it's the opposite. So to turn it into degrees, you times it by 180 over pi. And that's all you have to do. Now we can simplify. Simplify the pi from the top line and the bottom line. 4 and 180, that cancels, that becomes 45. And then 5 lots of 45, 200, so that's 225. Don't forget the symbol, degrees. So I did all that without a calculator. Hopefully you don't need to, just to simplify. Alright, so I'm going to do some examples of other stuff in just a second. I'll clear the board off. Oh, you tens. Okay, so what we're going to do, to work out what sine 150 is, we're going to use our exact value triangles, or the ratios. So, from our ratios we just did, sine 150 degrees, I don't remember there being a sine 150, and there wasn't, so we can't actually do it. So, what are we going to do? We're going to work out what equals sine 150. This is where last lesson comes in. So, what we need to do is draw an exact value triangle. Sorry, draw a unit circle, that's what I meant to say, and then we'll use exact value triangles. Alright, so remember, if you want to put all this in, 90, 180, 270, and 360 or 0 goes there. Alright, so we're going to solve sine 150. So start off at 0 and we go around to 150 degrees, which is there. That's 150, isn't it? That angle is 150. So that's not the angle that we need. We want a reference angle. So a reference angle is always taken from the horizontal, which is here. And the difference in there is 30 degrees. That angle is 30 degrees. So we know that sine 150, or right here, sine 150 degrees is equal to sine of our reference angle, which is 30 degrees. But just wait for a sec, all stops to city. So sine is positive in that one, so we just leave it like that. It's positive 30 degrees. And so now that we've worked out that is the same as sine 30, we can look at our exact value triangles, and we know that sine 30 is equal to a half. You just read that off those ratios we had a second ago. And there's your answer. So you can say sine 150 is equal to 1/2. Excellent. Let's move on to the next one. Tan 135 degrees. That's not in my ratios, so what do? We do a unit circle again. Not very neat, but oh well. So there's our unit circle. And 135 degrees. There's 90. Okay, so it's about that way. That's 135 degrees. Excellent. So if that's 180, then I reckon this reference angle would be 45 degrees. Great. So let's work out all stops to city. You need that to work out what's positive. Okay, so let's work out. So tan 135 degrees is equal to tan 45 degrees, because that's our reference angle. But we notice in this quadrant, the second quadrant, only sine is positive. What have we got? We've got tan. So tan is negative. So tan of 135 is equal to negative tan 45. That's our first step. Now we have to look at our exact value ratios we just had. And tan 45 was equal to 1, because remember it was 1 over 1, which is 1. So tan 45 is 1, but it's a negative. So we write down negative 1, and there you have it. So now over here, you can do your exercise. Exercise 4J, you need to look on the course outline because I haven't written it up. And don't forget, smash that like button.